Hi all, welcome to another Shouting Electronics. Today on the workbench we have got this Centurion, I don't know if you can see it there, it's Centurion Lattice Proximity Access Control System. Basically, this is a tag, after I finish bumping around, this is a tag system to open up a door. This is internal to one of my customers' premises. Now if we take a registered tag, this must be James Bond's tag because as soon as I bring it near, it detects tag number 7 that is in the memory, and you can hear the relay clicks. So basically it's given this tag access to open the door. If we take a tag that hasn't been programmed into the unit, it says NIC not in controller, so this tag won't work. Now the way to add a new tag is you're supposed to take a master tag, which this is not, but you would just hold it on there for 5 seconds. It should give something like admin or something, and then brings you into a menu where you can just tap the new tag and then release it with this one. And in the manual it warns you, do not lose your master tag. So what do you do? What do you do if you're the customer? You lose your master tag, which means without that master tag we cannot add any more new tags into the system. I've tried various ways of factory resetting this based on previous experience with Centurion systems. For example, linking the free exit input to ground, starting up the unit, but no combination of inputs I've tried or anything will default this so that I can add new tags, new admin tags, and then once I've added new admin tag, then I could add the rest. Of course, that's not happening, so I think we have to get a bit creative with this. From what I heard from my supplier as well, that they're not actually doing the Lattice systems anymore, and the solar, which is strange, but anyway. Let's just take a look at the inside of the unit, shall we? Move my little stand out the way. And a little bit of dirt. Okay, so you got your front cover. You got your little back cover that slides over the unit. So we'll move that out the way. So as you can see, we've got our relay to control the door lock on those outputs there. Common, normally open, normally closed. You got RS485 for networking. You got the RX and TX that you can connect to secondary heads that you want to read from, different pickup heads. Then you got your 15 volts AC, 15 volts DC, 12 volts AC inputs here. You got a button or input for a free exit or fire button that if anyone pushes this button or activates this input, it does the same thing as releasing without the tag. You've got a door sense input that basically, from what I read on the manual, if the door is left open for a certain amount of time, it sets off the alarm. Or if the door is opened without this giving access to it. If it sees the door mag switch has opened, then it knows, okay, somebody's tampered with the door. It's also got this plus and minus and CHD plus, CHD minus and CHD. That's used to go to their wireless transmitters and things, their secure transmitters. Then if we look over here, we've got some power devices there. It looks like a voltage regulator maybe. Over here we've got our bridge rectifier, a buzzer. We've got, I think it's a Texas Instruments chip that's designed for reading RFID tags. We have got some nice big chunky diodes over there. This input here is used to set sensitivity, so if you mount this thing on a metal box, you have to put a bridge on there to make it more sensitive. I don't know, there's nothing in the documentation about these pins. I've also tried shorting some of them out, it doesn't default the units. The microprocessor is a PIC 18F6722. Yeah, 6722. And then over here we have got a memory chip. I presume the main program is actually stored in the controller, in the microchip controller, and then the memory chip is used for storing the tags and the configuration. So I think that might be an attack vector that we can try to default this unit. We'll pull out that memory chip, see if we can read it, see maybe if they haven't encrypted it or whatever, maybe we can just wipe it out. Unit sees this default and it's happy, or maybe we go and somehow swap it around, swap tag numbers, so that one of these tags that I've got would become the master tag. I think that we'll go, just for interest's sake, dump that Eeprom and check it out. Also over here we've got the 75176 That is the RS485 driver for communicating along the network back to a PC and between the units and that. So I think the first we're going to do, we're going to pull this SPI Eeprom. We're going to hook it up to Arduino Uno and just try dump the memory and see, because I don't have an Eeprom reader. We'll just dump it like that and check what happens. Back of the board, we've got our 3x7 segment LED displays, and we have got the antenna going around the circumference of the board. So you can see it starts on this side over here, goes all the way around, comes back there. There's a little stub going in there. I don't know much about antenna theory and that, and you've got a whole little network over here to tune the antenna and everything. And if we look at the spec sheet for the unit, okay, we look for the tags, 13.56 megahertz tag. So that's the frequency this sends out to the tags to charge them, and then they start shunting it down. There are a lot of videos on how RFID works, so you can just go and research that more if you're interested. This can do 1,000 tags, this specific reader, and it can read them from 80 to 100 millimeters, so 8 to 10 centimeters away. Definitely not enough to go and scan somebody's card as they're just busy walking with it in their pockets. Okay, so time to get medieval. And I can switch the hot air station off because it's pointing right in my face. Okay, so let's take a look. What model it is, or what EEPROM it is. Don't know if you can read it there yet. It's a microchip. Uh, 25LC 912. 25LC 512. Microchip 25LC 512. Okay, so now the trick is, this is not a PDIP. This is a very small component. So I need to try put this onto a breadboard so that I can hook it up to my Arduino Uno, or I could dead bug it. Let's see what I'm going to do. Okay, I do not have a breakout board for a SOP to PDIP. So that would have been perfect for mounting it onto a breadboard. So what I'm going to do is I'm just going to put it onto this board over here. This SMD practice soldering board. Sorry if that's out of focus. So this is actually a solder practice board that was sent to me as part of a box filler by Mr. Sean B. He is a member of the EEV blog forums. Very nice chap who stays about 120 kilometers away from me. Kilometers, not miles. We are South African, so I'm just going to put this chip onto this board to give me more stability so I can solder some wires. Basically I'm going to be soldering them onto the legs, but I don't want the chip to go dancing around. It doesn't fit the outline properly, so I guess it's just going to give me a bit of support, not all four legs. It probably would fit the outline properly if I SMD soldered it or hot air soldered it, but like I say, it's just for a bit of support. So now I need to pull up the data sheet and then see what pins I need to connect on this to what pins I need to connect onto the Arduino Uno. So I think it will go straight onto some solid core wire that's going to just plug into the pins on the Arduino. It should be that simple. Okay, it does look a bit messy. I used some cable from a screen for a laptop LCD monitor, so it is stranded cable with, this one's got silk or whatever inside it, so it makes it fun. Okay, so using the Arduino documentation, Introduction to the Serial Peripheral Interface, links in the description. I connected Eeprom pin 1 to Arduino pin 10. Pin 2 went to Arduino pin 12. Pin 5 went to Arduino 11. Pin 6 to Arduino pin 13. Ground was connected to 3, 7 and 8. Oh, sorry, 3, 7 and 8 was connected to plus 5 volts because this is a 5 volt current device. And then ground was connected to pin 4, and that's basically all it should be. So now it's just a bit of working in the Arduino environment. Let me hook this up and just see what happens. As a side note, let's just see what this unit does. If it shows anything without the EEPROM. Maybe it hangs if it can't find it, or if it can't find a bit of initialization code or whatever. That would be bad, because then it means I can't just bomb the EEPROM. That without a quick and easy insertion and removal method, it's not going to be fun reprogramming the whole time. But let's take a look. Don't know if you can hear that tuck tuck. So it's fast beating. It might be in a boot loop. Well, I was trying to find the EEPROM because obviously it's no use running without the EEPROM. Okay, so let me get a cable plugged into the Uno, get some software loaded, and we'll see if we can first see this EEPROM. Okay, now I could have gone the easy route and went with one of the USB SPI EEPROM reader writers that you use for flashing BIOS and that. But I thought since I've got the Arduino Uno, it's got the USB and it's got the SPI interface, we just use that, so I got it. Okay, so now I'm going to show you if this works. Screen capture from my laptop. Okay, now unfortunately my screen capture on my laptop is up to poor today. It's only capturing about 30 seconds and then it dies. So I'll just have to do it this old-fashioned way, point the camera at the screen. Okay, but let me show you what I'm doing here. Okay, I've got this EEPROM SPI Wii library, or WE, by Wolfgang Ewald, so I guess it's WE. Okay, this is for the 25 series, or in any EEPROM in that series, that's SPI basically. Okay, there's the details if you want to go to those sites there. Okay, so basically it includes, I have modified his example programs just to dump basically what I want to dump. I want to dump the whole memory contents. Okay, so I'm including the SPI library, I'm including the EEPROM library that he made. That's just the pins that it's connected to, as I discussed before. Ignore everything that's commented out. Creates a new instance, and it turns on the serial ports on the Arduino at 11.5200. And you'll see why we got this delay of 3 seconds later on. So basically it's going to try and initialize the EEPROM. If it sees it, then good, it carries on. If not, it goes in, it's supposed to print out to the serial print and then waits in an infinite loop, so it doesn't do anything. I blanked that out. The default speed is 8 megahertz, so we're going to be reading this chip at 8 megahertz. Okay, page size I set to 128 because that's what the data sheet for this chip said. And now you'll see over here, I want to read all the bytes from 0 to 64 kilobytes. Now the reason we do that is because this is a 5112 kilobit memory. If you take a kilobit, it's converted to bytes, you divide by 8, so that's 64K. Okay, so it's basically going to read it, let's do a serial write, not a serial print because I want raw data. Serial print goes and messes up the raw data. So serial write, and then it just loops through. Once it's done all of that, that's it, the program is over. Okay, so I am going to just upload this to the Arduino for the moment. Okay, it says done uploading down there. Okay, I've loaded another app onto my laptop as well. It's called Grab Serial, okay? That's basically going to take the raw data from the serial ports and dump it into a file. So how does that work? Okay, Grab Serial, verbose. The device is dev TTY USB 0, which if you go into the Arduino IDE, you can see that it is TTY USB 0 that the Arduino is hooked up to. The baud rate, 115200, same as we set in that serial program. 8, none, and 1, that's the defaults. I'm going to do a timeout of 10 minutes. Okay, although we probably won't need that long for it to read all the data. And then we're going to save it to a file called grab1. Okay, now what I am going to do, I'm going to show you now. Okay, there is probably a more elegant way to do this. But basically, I am going to hold the reset button on the Arduino Uno because I want this to start at 0. Okay, so I'll hold the reset button. Maybe I should hold it with this finger. And then I'm going to start the grabbing program. Okay, once I push enter, then I can let go of the reset button and it'll start after 3 seconds, busy reading all that data and pushing it out. You should, if I remember right, hopefully we'll have a beep here. If not, it could be because my sound's up to pawpaw on my laptop as well. Okay, so I'm going to start this and I'm going to let go of the button within that 3 seconds. And there we go. So I'm sure at 115, 200 it's not going to take us long. Let's open up another terminal. And there you can see it's already done 64K and 1, probably just because of the way I did my loop. So in other words, it is done, so I can actually stop the grab serial now. Now we can throw the Uno away, I'm just kidding. Okay, let's go look at our file now. Now it has saved as grab1 as we saw. I've installed a hex edit by using sudo apt get install hex edit, I believe. But now let's go into that file and see exactly what it's got. Hex edit grab1. Okay, now if you look over here, it's a lot to look at, but let's go. So we've got a whole bunch of bytes over there, and then it's a long set of blanks, and we've got some more bytes over there, stops over there, there's a one over there in the middle of nowhere for some reason. Then we go back down here, and we've got some more there, and it carries on for about 8 or 9. So I'm thinking that the serial number of each of these tags, when it was learnt, it's actually saved in there, I think. So in other words, the very first tag, the admin tag, should be this D7B31B04. So what I could do is take my tag, figure out which is number 7 here, copy those bytes over there and write it back into the EEPROM, to the EEPROM. But what I'm thinking is let me wipe out the EEPROM, move it back, put it back into the device, and just see, maybe it will reinitialize it as a blank EEPROM and then I can reload the tags. So let's give that a shot. Okay, I've got another, I modified his other program there, his other example. Hope you can see this. This is basically his EEPROM erase routine, okay? Basically, I think I've actually just kept it all, so it's just going to do that. It does a few things. Let's go through his program. Okay, let's see. Okay, so if we look at his program over here, I was looking too low. Set sensitivity is 42. Puts it into the EEPROM in position 10. Okay. It then gets it back from the EEPROM position 10. And it prints it so we can still see if it's 42. Okay, then it erases the EEPROM using this, my EEP.erase completes EEPROM. Then it gets it again, and it prints it. So if it erases the complete EEPROM, that should not be 42. That shouldn't be the answer to the life, universe, and everything. So let's go and run it. Why not? And just run it straight. This is done uploading. Let me just reset just in case. Now I'm going to do the same thing. I'm not going to show you. Okay, put Control C. Okay, I'm going to do this as grab2 now, because now this should be an empty EEPROM. So let's go back to the reading program. Sorry for my jumping around like that. Okay, dump. Okay, going to hold reset and run it and let it go. Give it a few seconds. Okay, Control C, ls dash list for grab 2. Oh, looks like I didn't do it for long enough, so let's run it again. Oh, Mr. Johnny Castaway. Think that's about it? Yeah, let's try. There we go, 64001. So let's hex edit grab 2, and there we go. We've got a blank EEPROM. They are all FFs, FF, all the way down. So this EEPROM is blank. So now I'm going to take it, disconnect all my millions of wires there. Turn on autofocus. Yeah, so now I'm going to disconnect all my wires. Going to take the chip out, put it back into the device, and let's see what it does. Now this might work, just depends on how their program is designed to initialize, or if it has some values stored in the EEPROM that it likes. And that's the software version, code 1015. Now the test, is it going to accept this tag as a master? There, did you see? ADM. So I think it saw this one as an administrator tag then. Now I think this unit, the administrator tag, can't be used to open and close. The administrator tag, yeah, see, admin. It can only be used to program more tags. So let me try program in. Let me see this tag. Okay, let me reset here. Okay, so I'm not in controller. Okay, so my tag is not in controller, but the admin tag is. Quick learn. Admin tag for 5 seconds, it'll go learn. And then tap tag 1. Okay. 2, 3, 4, 5. Learn. Tag my tag. Tag 1. Tap this one again, I think. 4. Okay, now that's gone into a different menu. So that's going into a different menu now. So, but now my tag should be 001. And this tag should be admin. So it does administration, but it won't open the door. Take my tag. And you can see that here the relay click and the light comes on. So I think that's all we had to do, was just erase that EEPROM. Program in this tag as the master, which we couldn't do because the EEPROM had a master tag in it already. And there we go. So now I can go take it back to site and go and program in the remainder of the tags. That is nice. Cool. Okay. Oh, yeah, I wondered why it said admin. It's because I'm busy waving it around over the tag instead of waving the tag over it. I do need to solder the buzzer back in. I forgot about that. You guys might have noticed I had the power on there. but now it's off. Okay. Buzzer. Okay. To throw parts on the floor. That's what we do here in the lab. Okay, there is other settings you can go through with the admin tag, like durations that it must activate for and that. But that I can always finalize on site. Okay, that is in place. I do need a jumper because this is mounting on brickwork. So I do need a jumper on there. And then do one last test, make sure I didn't break anything by squeezing it in now. Of course, my tag, as you saw in the beginning of the video, was 007. Now it's 001, so it's a no more James Bond tag. But that's okay. Who needs a James Bond tag anyway? And that is all she wrote. So basically we sorted this out without having to buy any more parts. I didn't need to buy a replacement Eeprom. I didn't have to buy a whole new reader. I didn't have to buy an Eeprom programmer either, even because I had the good old trusty Arduino Uno. So I hope you learned something. It was an interesting thing. I've learned about reading and writing to SPI Eeprom because I've only ever used the internal Eeprom on the Arduino. But anyway, that's been an interesting learning for me too. I hope you've learned something. If you did like this video, give it a thumbs up. I don't know which corner it'll be, probably that corner. And like and subscribe and share with your friends. Thanks guys. Hope you enjoyed it.